Game 4. The scenario here gives us another floating grouping game. We have 3 different groups, which are the 3 bouquets, and 5 things to put in those groups, the 5 flowers. This game is a lot more open-ended than a lot of games. They do tell us that we have to have at least 1 flower in each bouquet, but they don't tell us that we have to use each flower. So for all we know, we could just use P, R, and S and never use L and T. It also doesn't tell us how many flowers go in each bouquet. So for all I know, we could put 3 flowers in bouquet 1 and only 1 flower in bouquet 2. And finally, it doesn't tell us that we have to use any of the flowers only once. So we could possibly put roses in all 3 bouquets. So when the test maker doesn't specify some stuff that we normally expect to be specified, we need to make sure that we recognize that we don't assume that it's just like every other game. Still, what we have is enough to let us set up some things. We know we have 3 bouquets, so we can make 3 categories. We know that each bouquet needs at least 1 flower, so we can put 1 space under each. And we know that we have 5 flowers to work with, so we can list them out to the side in a roster. And that's about all we can do before we go on to the rules, so let's go on to those rules. There's a lot of rules here. Let's take them one at a time. The first rule says that bouquets 1 and 3 can't have anything in common. We can represent this as a formal logic rule or a conditional rule. If something is in bouquet 1, it's not allowed to be in bouquet 3, and vice versa. So 1 means no 3, and 3 means no 1. A given flower can't be in both bouquets, but it doesn't have to be in either, so we know we can't see an L in both 1 and 3, but we don't know that we have to see an L in either. Now, Rule 2 says that bouquets 2 and 3 need to have exactly 2 kinds of flowers in common, which is a lot to unpack. The first thing it's going to mean is that we're going to need an extra row of spaces for bouquets 2 and 3. You can't have 2 things in common if you only have 1 thing. We also need a symbol to indicate that those spaces are shared, so we'll put some equal signs in between them. And finally, we need a symbol to say that those are the only shared spaces that the 2 bouquets get. Any additional spaces won't be allowed to be the same. So we can handle that by drawing a line to say no more, and then putting a note that anything that comes after that line isn't allowed to be shared between 2 and 3. Rule 3 is a lot simpler. It just says that bouquet 3 needs to have a S, which we can symbolize by putting right over the top of the column. And the reason we're going to do that is we don't know if that S is going to be shared with bouquet 2 or not, so we don't know whether to put it above the line or below the line. Of course, if bouquet 3 has something, according to Rule 1, bouquet 1 is not allowed to have it, so we'll also need to indicate that bouquet 1 doesn't get an S. Rule 4 is a bit of formal logic, and a little bit of complicated formal logic. If a bouquet has L, then it must also have R, and it can't have S. So when we write that into formal logic, we're going to see L means R and not S. Of course, we also need the contrapositive. Remember, when you make the contrapositive, flip, negate, and then any ands need to swap over to ors, and any ors become ands. So the contrapositive here means if you don't have R, or you do have S, you're not allowed to have L. When you have multiple formal logic rules in the same game, keep their arrows lined up so that you can use it as a sort of checklist. Now this rule is going to have an immediate effect because since bouquet 3 has an S, it won't be allowed to have an L, and we can note that over the top. The final rule, another piece of formal logic, if something has a T, then it also has to have a P. So in formal logic, T means P, and then the contrapositive, no P means no T. Everything all organized as our little list. Ironically, when a game has a whole lot of conditional rules, it's assigned to not go trying to figure out a whole lot of inferences and deductions. We have a lot of rules and they can interact in a lot of different ways. One rule might trigger another rule and so on, but generally it's best to let the local questions, conditions trigger the rules, follow the chain of events that gets triggered, and then see where you are, rather than trying to figure out every possible iteration at the beginning. So we're going to go to the questions, and of course the optimal question order here is going to be actually the way that they're written. We like to do solution questions first, and 19 is a solution question. We like to do local questions next, and 20 and 21 are locals, and then after that we would do cleanup with 22 and 23, which are global. So, on to the questions.